Hi there. Here we will learn about a kind of production function which is famous for its functional form. It is known as the Pythagorean production function because it is very much similar to the Pythagorean theorem. Here you can see that it is very much similar because the value of one variable is actually the square root of the sum of the squares of the two. So before we go ahead, I suggest you subscribe to this channel and benefit from such rarely find material which can help you to polish your skills in quantitative economics. You may also click the bell icon so that you remain updated about the latest material. Now here, this is the production function in its standard form. It is based upon capital and labor, so k squared plus l squared whole square root. We can experiment with it just like we do it with every other production function. We can try to find out the marginal product primarily of labor and then of capital. Here you can see we have taken the derivative with respect to labor, and definitely it appears on the other side as well. Now we have to calculate its partial derivative, and for that we've converted this square root into whole power 1 over 2. So now power rule is easily applicable. This is the power and this is the deduction of 1 from the power, and this is the derivative while keeping the power 1. So this is the solution. You can pause the video and verify, and once we simplify it and rearrange it, we get this answer. So this is the marginal product of labor of the Pythagorean theorem, Pythagorean production function, and you can see that it is a function of capital and labor. Now it also shows the complementarity between the two. So let's talk about the MPK, and if you have found the MPL, you can easily find this because it is very much similar. Same rule will be applied. Only the difference would be related to the independent variable with respect to which we are trying to find out the derivative, and this time it will be capital instead of labor. So the answer will also have capital instead of labor here, and definitely here we'll write MPK. So again, it shows that there is complementarity between capital and labor, and both of them, they determine the marginal product of capital as well as marginal product of labor. Once we have both of the marginal products, it is very intuitive to find out the equilibrium condition of this producer, or in other words, the optimal factor combination condition. We know from the standard economic theory that this condition is this, so we can substitute the values of MPM and MPK. In the next step, you can see the same thing. So you see that we have substituted MPL and MPK, while the right hand side remains the same. Then we can reciprocalize the term in the denominator, and afterwards we can cancel out whatever is cancelable, and finally we will get the condition in this simpler form. This is known as the optimal factor combination condition of the Pythagorean production function. Now we can also experiment with this production function by finding out the homogeneity of it. So here we have written the function one more time, and here we are introducing a scalar, for instance, represented by lambda, wherever we find the two variables, that is capital and labor. So here you can see on the left hand side, both of them are augmented with lambda, and also on the right hand side, they have to be augmented with lambda. Now the simple process of simplification and expansion will happen. As you can see, we have separated the lambdas, and then we have taken it as a common factor, that is lambda squared. It is same as the original production function. So we can write it as Q, and if we do, we can also see the power of lambda, it is 1. So it shows that this production function is homogeneous, and it is homogeneous of degree 1, as the scalar has been completely factored out. So in this way, we have tried to do some treatment of the Pythagorean production function. Here we found the homogeneity of the set production function. We also found the optimal factor combination condition. We also found the marginal products. So this was about this production function. I hope you have learned from it. You may also like it if you have found it useful. Thank you.